Hello everyone and welcome to The Explainer. I am so thrilled you're joining me today because we are going to unpack something absolutely fascinating for anyone interested in AI, software architecture, and the future of developer tools. Today we're zeroing in on a highly innovative Claude Code plugin known as the Design Council. Look, if you've ever felt that asking an AI for architectural advice is, well, kind of like talking in an echo chamber, you are definitely not alone. This tool is built exactly for you. We're going to see how the Design Council completely transforms a standard, single-threaded AI conversation into a rigorous, multi-agent review panel.
Okay, let's dive into this. Here is our roadmap for the explainer. 1. The single context problem. 2. Enter the Design Council. 3. The 6-phase protocol. 4. Crosstalk and arbitration. And 5. Costs versus benefits.
Section 1. The single context problem. Escaping the yes man.
Let's start with the primary pain point developers are facing right now. When you're making a major cross-cutting design decision, you usually go to your AI assistant and you ask it a question. But the problem isn't the intelligence of the AI, it's the architecture of the chat itself. You are essentially dealing with a single context window that acts like a bit of a yes man to whatever framing you establish first. On the left, imagine you ask a standard Claude session, hey, should this API paginate cursor style or offset style? You're going to get one answer from one vantage point. And if you iterate in that same session, every subsequent turn inherits your prior reasoning. You're completely trapped in the same cognitive loop. But on the right, the Design Council approach isolates contexts, creating structural disagreement rather than a single inherited perspective.
Think about what actually happens in that standard session. So what happens when the security angle, the technical writing burden, and the mobile client constraints are all filtered sequentially through that exact same prior framing? Well, the reality is that these crucial independent perspectives are either entirely ignored or they become systematically incomplete. The AI gets primed by your first question, and it can never truly look at the problem with fresh, unbiased eyes from a different discipline's point of view. You end up with blind spots, and usually a system that breaks in production simply because a crucial perspective was ignored.
Section 2. Enter the Design Council, a structured multi-agent review panel.
So, how do we actually fix this? The Design Council fixes this structurally, rather than just telling you to, prompt harder or write some massive system instruction. It changes the fundamental architecture of the review process. By definition, the Design Council is a Claude Code plugin that convenes role-specialized peer agents to debate your technical decisions in real time. Each agent gets its own totally independent context. And what's really amazing is that the invoking Claude, the one you initially talked to, steps back and acts as the CEO, routing the disagreements and managing the team, rather than trying to answer the whole thing by itself.
Now, what's really interesting about this slide is the sheer scale and ambition of this tool. Up to 11. The plugin can spawn up to 11 independent seats at the table. We are talking about a massive parallel fan-out of distinct AI personas, all focusing on your single engineering problem at the exact same time.
Here's a look at what that dynamic roster can actually include. You have seats like the security engineer, the UI/UX designer, the performance engineer, and literally even legal compliance. The plugin is super smart about how it allocates resources too. It uses the heavy-duty Opus models for synthesis-heavy roles like your principal engineer or product manager. But for highly analytical, highly specific seats, like the performance engineer or QA, it deploys the faster Sonnet models. So the roster dynamically sizes itself based on exactly what you're building.
This quote right here, straight from the documentation, is the entire philosophy of this explainer. Disagreement is structural, not theatrical. Because these agents don't inherit your cached rationale, they genuinely argue their distinct domains. The security engineer knows absolutely nothing about the performance engineer's assumptions regarding batching. They clash, and they clash authentically. It's just like a real cross-discipline engineering review, just, without the passive-aggressive Slack messages. This produces the friction required for truly great engineering decisions.
Section 3. The 6-phase protocol. Under the hood. So how does a multi-agent architecture run without descending into pure chaos? Through a really rigorous 6-phase protocol. We're going to walk through these. Phase 0 actually starts before anything even spawns. The CEO shows you a plan card. This is a confirmation screen estimating the token budget, the wall clock time, and the roster. You have to explicitly approve it before spending a dime. Then we move into briefing, convening, crosstalk, arbitration, and finally teardown. Let's look a little closer at those early phases.
In Phase 1, the CEO gathers all the binding constraints from your project's memory and specs into a single brief.md file. Every single agent spawn prompt points to that exact same file path. And because they all read the identical file, this triggers prompt caching. This is a brilliant optimization, saving approximately 7,000 to 12,000 tokens per 8-seat council on constraint-heavy projects. That is a massive optimization that directly protects your API budget.
Then we hit the actual spawning in Phase 2. In a single multi-tool call message, the CEO spawns every seat in the background using Claude Code's team create commands. And crucially, Phase 2.5 is a handshake verification. The CEO checks to make sure every agent actually woke up. It looks for empty terminal pane IDs to remediate any silent spawn failures before the debate even begins. It's incredibly robust. Let's move to Section 4 and see how this builds. Crosstalk and arbitration, the boardroom dynamics. Let's look at the actual boardroom dynamics, because this is where the magic really happens. In Phase 3, the crosstalk phase, the agents post their opening verdicts. They will explicitly approve, raise concerns, or outright block a proposal. Then, they completely bypass the CEO and use direct peer DMs to argue live disagreements with each other, just like a real engineering review. Now, to keep this from spiraling into some infinite loop, there is a hard cap of 3 rounds of debate. And hey, if you just want a quick read without the debate, you can run it in review mode, which just skips crosstalk entirely. Once those 3 rounds are up, we hit Phase 4, arbitration. For any disagreements that the peers couldn't resolve themselves, the CEO steps back in. The CEO writes a structured 3 to 5 sentence decision, but here is the absolute key. The rationale must explicitly engage the losing argument. It doesn't just pick a winner, it documents exactly why the other concern was overridden. Finally, Phase 5. The team is shut down, but the output is preserved as a durable artifact. The final log includes the resolved disagreements, the arbitration decisions, and a file ownership execution plan for parallel implementation. And this log is saved directly to your local user directory, completely outside the project repository. That means even if you pivot branches, rename the repo, or completely scrap the code, your architectural decision log survives, meaning you never have to wonder, why do we build it this way 6 months down the line?
Section 5. Costs versus benefits, the ROI calculation.
We've seen the power, but let's take an objective look at the trade-offs here, because implementing an 11-model council isn't exactly lightweight. So the crucial point is this ROI calculation. The pros are absolutely massive. Genuine parallelism, structurally independent perspectives, and highly durable logs. But look at the cons. You are looking at a 10 to 20 times token cost multiplier compared to a single context review. However, because they run concurrently, the wall clock time is roughly equal to the slowest seat, not the sum of all seats. It's basically an upfront investment of tokens to save you time and future technical debt down the road.
Because of that cost, the documentation provides very strict, pragmatic advice on when to actually use this tool. You should invoke the council when a decision crosses 2 or more specialist domains. For example, data schema choices that impact both downstream integration and performance, or infrastructure choices with major security trade-offs. And crucially, do not invoke this for simple bug fixes or picking a standard library. The token cost simply isn't justified for minor tweaks.
I want to leave you with this provocative question to ponder. As our systems grow more and more complex, is the structural rigor of a parallel multi-agent debate worth trading the simplicity of your traditional single-context AI chat? After seeing what the Design Council can do, I think for those critical foundational architecture decisions, the answer is a resounding yes. Thank you so much for joining me to explore this incredible leap in developer tools. I really hope this helps you reconsider how you architect your own LLM workflows moving forward.